All right, here are solutions for quiz 5 for Math 251. So in this first problem, you're asked to show that the derivative of tangent equals secant squared, and I give you some hints here. And the trick, as we saw in class, is to recognize that tangent of x is the exact same as sine of x over cosine of x. And because you have that fact and you know that the derivative of sine is cosine and the derivative of cosine is negative sine, we can use the quotient rule. So maybe I'll write this off to the side. That doesn't say quotient. Quotient rule. Playing the role of f, our numerator in the quotient, is sine of x. And playing the role of g is cosine of x. And then f prime, the derivative of sine of x is cosine of x, as stated above. And g prime would be negative sine of x. So if we take all these pieces, we can apply our quotient rule to get that the derivative of f over g is f prime, so cosine of x, times g, which is cosine of x, minus g prime, minus a negative, so I'll just write plus, sine of x times f sine of x, all divided by g squared, so cosine of x squared. So really up in the numerator, I got sine squared x plus cosine squared x. And in the denominator, I got cosine squared x. So one way you could simplify this is you could use your Pythagorean identity in the numerator and say, wait, sine squared plus cosine squared for any angle is just 1. So I got 1 over cosine squared x, which is the same because 1 over cosine is secant. Secant squared is 1 squared over cosine squared. So I get that this is equal to secant squared x, which is what I was trying to prove from the get-go. And now that I have that fact, I guess I can move on and solve some derivatives. So this one asks you to find the derivative of secant times tangent. And I give you the derivative of secant and then the derivative of tangent we have above. So I guess I can use the product rule. Playing the role of f is secant of x, and playing the role of g is tangent of x. And therefore f prime, the derivative of secant, is given here to be secant times tangent. And g prime, the derivative of tangent, as we saw on the previous page, was secant squared. So now I take all these pieces and I put them together using the product rule. The product rule says the derivative of f times g is f prime, so secant of x times tangent of x, times g, tangent of x, plus g prime, which is secant squared x, times f, which is secant of x. Maybe I'll write or, because I don't care that you simplify this, secant of x, tangent squared x, plus secant cubed x. Or if you want to factor out a secant, I suppose you could. Secant of x times tangent squared x, plus secant squared x. Or however else you decide to write this. But really, any of these answers are totally fine by me. So I'll make a big old box and put them all in there. What about this one? The derivative of tangent plus secant. Well, you got options. You could use the chain rule now that we know it. But at this point, you may not have known the chain rule. So what I'm going to do is instead going to use the product rule again. Playing the role of f is tangent of x plus secant of x. And the role of g is actually also tangent of x plus secant of x. Because really when I'm squaring something, I'm multiplying it by itself. So what I got to figure out are these derivatives. F prime, well the derivative of f is the derivative of tangent plus the derivative of secant, and the derivative of tangent we already saw is secant squared x. And the derivative of secant is secant times tangent. And that thing is going to be the exact same as g prime, so I'm not even going to bother writing it again. And now that I have all these pieces, I can throw them together and say that my derivative is f prime, so secant squared x plus secant of x tangent of x, times g, which is tangent of x plus secant of x, plus g prime, which again is this mess, secant squared x plus secant of x tangent of x, times f, which is tangent of x plus secant of x. Or you might recognize that this term and this term are the exact same. So I got two of these things. I have two of these, I don't know, tangent of x plus secant of x times secant squared x plus secant of x tangent of x things. And this you could have gotten to directly from the chain rule. You could say your outside function is all this stuff being squared. So 2 times all this to the first power is what I have here. And the derivative of the inside is what I have here. So again, big old box. Either of those answers are totally fine by me. We'll move on to the last one. This one's kind of a mess. Unless you happen to know some trig identities, it gets a little bit easier. Note that tangent squared is sine over cosine. And I think I gave you that on the first page, maybe. Yeah, tangent is sine over cosine, and secant is 1 over cosine. So I can rewrite this. I can say this is the derivative of, maybe first I'll say it's the derivative of tangent of x over secant of x, all squared. Because when you're squaring a quotient, you square the numerator and the denominator. So I could go from this to this. But what's nice about this, so I got some stuff being squared here. Tangent of x is sine over cosine. And secant of x is 1 over cosine. And so when I divide these two fractions by multiplying by the reciprocal, what I get is the cosines cancel out, and I'm left with just sine of x that's being squared. And this derivative is a lot easier to take. I could either use the chain rule if I knew it, or I could use the product rule again and say that f is sine of x, and as is g. Sure, I'll write them both. And the derivative of sine is cosine. So I get f prime g, so that's cosine of x times sine of x plus g prime f. Yeah, that's all right. Which is cosine of x times sine of x. Oh, hey, I got two of these sine of x, cosine of x things. Sure do. Which we could have gotten from the chain rule. Bring the 2 down in front, leave the sine alone, multiply by the derivative of sine, which is cosine. So either of those answers work, or some huge mess. Maybe I'll write, or a huge mess from double product rule inside quotient rule. Which I'm going to go ahead and let you figure out. Maybe we've done some of those parts up here. Maybe not. I'm not sure. But if you just saw this is f and this is g in the quotient rule, you could do it that way too. But I prefer to do it one of these two ways. So I'm going to call that good and end the video here.